Hello friends. Today we'll discuss about biodiesel. What is biodiesel? Biodiesel, this is a kind of alternative biofuel, alternative fuel that can be used in any engines. But before using in the engines, we must know its property, how it is produced, what are the feedstock, what are the basic trans-esterification reaction. That is the whole backbone of biodiesel production. We'll discuss about the feedstock quality, what is their content, how the reaction is going on, and actually biodiesel, if chemically, if you define, this is a long chain um, alkyl ester. It may be methyl, it may be ethyl, it may be propyl. You can see this is the actual biodiesel that has been produced, right? And this biodiesel color, you can see this is a different color. This is this can be blended. B100 is often used for blending, and we'll discuss what is B100 blending. But first we'll discuss about the um, chemical reaction, trans-esterification reaction. If what is trans-esterification? We can define trans-esterification of fat, any kind of triglyceride, where fatty acid methyl ester and glycerol can be formed. And if we talk about the reactions, 1 molecule of triglyceride is required, while 3 mole of methanol is required, and then 3 mole of methyl ester is formed along with 1 mole of glycerol. Glycerol is a byproduct, while the main product is methyl ester, and this is the actually biodiesel. Methyl ester. This methyl ester is the biodiesel. All right. So let us start with the trans-esterification reaction. Trans-esterification of fat is essential to form the actual biodiesel. You can see this is the 3-methyl ester, which is formed by 3 mole of methanol when react with the triglyceride and form 1 molecule of glycerol. And whatever the R group, alkyl group is there, there is no change in the alkyl group. But this reaction requires strong catalyst. This may be base, this may be acid. We'll discuss later on. Why what are the some advantages, what are the some disadvantages. But actually the catalyst is required, where methanol can attacks 1 molecule of glyceride, especially if you'll see the triglyceride is broken down into the diglyceride, and 1 mole of glyceride that is left over methoxy acid that is produced by the breakdown of methanol is going to react with them and then form the methyl ester and 1 molecule of glycerol. Glycerol is a byproduct. It's not desirable, because if glycerol is present in very high amount, they can produce problem in the engines. They can produce problem in the injectors. They can create problem in the valves. So whatever the vehicle, if you are using such a methyl ester where glycerol is absent, and then it's better, because it's going to increase the life of engines. Otherwise, what will happen if glycerol is there? They will their density is more. They are more viscous. The quality of burning, quality of fuel will be reduced. So this is not desirable. So in this slide, we'll discuss why biodiesel, what are the industrial prospects of biodiesel production, how industrially they can be produced, and basically we'll discuss more about the trans-esterification, which is the sole cause of this biodiesel production, right? So in the next step, a little bit of historical aspect. Rudolf Diesel was the first man to think about biodiesel, where he basically used peanut oil to make the biodiesel. Actually, if you'll see, there is standard norms of biodiesel. Often this is indicated in the term of B100. B100 means blending. If 100% biodiesel you are using in the engine, this is called as a B100. And if you are using the B20, means 20% biodiesel is mixed or blended with any petroleum diesel. That is very good. That's not creating any problem, and also they are not affecting any kind of heating value or calorific value. So everything remains the same, and also blending don't require any kind of engine modification, but some problem exists with the biodiesel today. That's why we are discussing. We'll discuss more about the trans-esterification. These all side effect. These all um, effects are related to the engines. The question is there? Is there any modification required in the engines, and can biodiesel be easily produced in the house? What are the basic steps? What are the problems? Is this economical to produce it? It's a very so. What is biodiesel? If you'll see, any kind of plant or animal lipids or oil can be used for biodiesel production. Plant-based oils like soybean oil can be used, cottonseed oil can be used, sunflower oil can be used for biodiesel production, and then animal fat can be used like beef tallow we can use, pork lard can be used, poultry fat can be used. All these are the feedstock, but actually, if you'll see, the quality of feedstock decides the quality of biodiesel. For example, if we are using the algae for biodiesel production, they contain very high polyunsaturated fatty acid, and polyunsaturated fatty acid is not desirable in the diesel production because this creates a gel biodiesel. Do you know about the gel biodiesel? Gel biodiesel is a kind of biodiesel which, if stored at very low temperature, they are converted into the gel form, and they are not suitable for the fuel purpose because if you are using them for the fuel purpose, they will create problem in the injectors, and engines may get seized, and there may be any kind of other problems. So, what is the desirable? Desirable, we'll discuss. Desirable is that the plant should contain high saturated content. Some monosaturated content is also allowed, but there's very low poly unsaturated fatty acid. And if you want to know what are other the feedstock can be used, the grease can be used, yellow grease can be used, any kind of cooking oil can be used. They can be converted into the biodiesel. So, in summary, we can see biodiesel is a kind of alternative fuel for diesel engine. They can be made from any vegetable or animal fat. They are meeting all the health effect testing, and they are almost non-toxic, non-harmful. They are not damaging the health or creating any kind of pollutants. Very low emission of carbon monoxide or carbon dioxide is there because they are greenhouse gases, and all the diesel produces very high quantity of CO2. That creates enormous problems in the form of greenhouse gases. High flash points should be there, and which already biodiesel have. High flash point is there, and they are safer to use, and they are also degradable, biodegradable. Many microbes are there that can attack and that can convert them again into the water and other form of usable product that can further be broken by the some microbes. So biodegradable is the most higher quality. This is the most important, very important property. They are biodegradable as compared to the diesel. If you say they are, if you are storing, if you are throwing the diesel, they are not going to be degradable easily, while they also releases a very high amount of CO2. CO2 emission is very high, and they are creating a large amount of health problem, and also they have very limited stock, so there is urgent need to form the biodiesel. Biodiesel is actually monoalkyl ester that can be produced from triglyceride ester. So you can see the biodiesel reaction, very simple reaction is involved. In the biodiesel reaction, there is a esterification or trans-esterification is there, and biodiesel actually methanol can be used, ethanol can be, any kind of alcohol can be used, which can react with the triglycerides, and then you can see the mixture of alkyl ester is obtained because this is a multi-step process. This is not a single step process, a multi-step process is there, and alcohol In presence of catalyst, take to triglyceride one by one, the first molecule, second molecule, and third molecule, and then you can see the separate. There is a separate production of alkyl ester, and a large amount of around 10% of glycerol is produced during the trans-esterification. So the catalyst is very important. If you are using a metal catalyst, then there is a large amount of production of soap. If you are not using metal catalyst, then avoided formation of soap can be avoided. Formation of soap is not desirable because economically this is unfeasible, and also they are going to degrade the quality, and also I will say the glycerol is not required. Glycerol purification is done, and glycerol purification, without glycerol purification you cannot go for the production. So actually you can see the reaction where methoxide is going to react with each molecule of triglyceride separately, and they are converting them into the monoalkyl ester or methyl alkyl ester one by one. So this is a kind of um, uh, a reaction in which methoxide ion is formed, and the catalyst, whatever the catalyst you are using the base catalyst, you are using the acid catalyst, they are actually regenerating this methoxide catalyst, and these methoxide catalysts are attacking the molecule of triglyceride one by one. And if you see the reaction, methanol is the main catalyst that is added for the trans-esterification reaction with vegetable oil or animal fat or waste, and there are various processes involved for performing the complete trans-esterification. Trans-esterification must be complete. There are some steps, there are some precautions which can be done to complete trans-esterification, otherwise a lot of glycerol will be produced, and then you can see that crude biodiesel is produced, and they undergo refining to produce biodiesel, and crude glycerine can be separated, and uh, they can be processed for obtaining a very high quality of glycerol, glycerine that is used in the cosmetics and other industries. They are very important part, and they can be recovered, they can be sold out, and economically they can balance the overall cost of biodiesel production. And whatever the catalyst you are using, whatever the methanol you are using, they can be recovered by some additional steps. If you'll see, we can summarize the whole reaction as a vegetable oil mixed with the methanol catalyst, and in presence of base or acid, there is a trans-esterification reaction, and in the trans-esterification reaction, um, there is a separate multi-step process occurring in which methoxyanion is reacting with the oil or lipid, and they produces a biodiesel, glycerine, and then washing and drying can be done to obtain the pure biodiesel, and some chemical reaction you can obtain the crude glycerine. And for example, if you can say, if you have soybean oil, the first seed must be broken down to obtain a large amount of oil. This is called as oil extraction. Oil extraction, I will see, whatever the crude oil that is extracted, they are very viscous, and therefore a degumming process is there to remove out all those components that are undesirable and that are present in the soya bean. All right, and then esterification is performed, and after the esterification, you can obtain the crude biodiesel. And if you are using the sodium or potassium hydroxide, and the chemical reaction goes on, they also increases the rate of reaction and esterification, and biodiesel refining is done to recover the pure biodiesel, and also to recover methyl alcohol, which again can be used. Industry, you can understand there are various multi steps are there in obtaining the biodiesel. This is the container that contains pure oil, and then oil is heated to 120 degrees centigrade, um, and then titration, by titration level the quality is checked. If they having the proper ratio of feedstock, because I have discussed that there should not be unsaturated fatty acid. More desirable oil content should contain saturated fatty acid and unsaturated fatty acid. Low pH should be there, and by the help of iodine reaction, you can check the quality of feedstock. All right, and then the separate reaction in separate tank. Lye can be mixed, lye is NaOH, that it can be mixed in the mixing tub containing processed oil, and then processor. In the processor there is a uniform mixing is essential, because if uniform mixing will not be there, there will be incomplete trans-esterification, which is not desirable. So therefore, homogeneous mixing is done 3 to 4 hours, maybe time may be increased, and there's require certain temperature and pH that can be maintained to complete the trans-esterification. This is a matter of research. What kind of environment is suitable, because this is varies from oil to oil. Finally, biodiesel can be purified. Biodiesel and glycerin both are present in a single vessel. The glycerin settles down at the bottom because of high viscosity, while biodiesel remains in the upper portion, and then further processing can be done to separate out the glycerin, and then biodiesel can be separated. A little bit of feedstock. There are various feedstock. I have discussed that there should be proper ratio of oil content. You can see there are various feedstock. Canola is there, sunflower is there, safflower is there, corn is there, olive is there, soybean, peanut, cottonseed, yellow grease, lard, beef, tallow, palm, coconut. So all the animal or plant oil can be used. There is no problem, but we have to see these lines. These lines indicates presence of polyunsaturated fatty acid, which is undesirable because they produces high amount of gel biodiesel. So canola, a little bit of PF is there. Safflower, very high amount of PF is there. Sunflower, high amount of PF is there. Olive oil, very high amount of PF is there. Soybean, a little bit of less PFA is there. Peanut oil, more lesser content of PFA. Cottonseed very high. You can see beef tallow, very low amount of PFA. Coconut oil, very less amount of PFA is there. Palm oil, very less amount of PFA is there. And so therefore, based on the presence of saturated monounsaturated polyunsaturated ratio, actual feedstock is decided, because feedstock, whatever the biodiesel will be produced, their quality must be good. They should not degrade easily because of someone wanted components, and also water should be very less than 0.1%, and whatever the uh, poly PFA is there. PFA is going to create problem during the storage of biodiesel. If you are going to store the biodiesel in a tanker at lower temperature, these effects, these presence of PFA will create such a biodiesel which will freeze, which will form solid portion inside the tanker, inside the engine. So this is not desirable, because if they are not liquid, they cannot be utilized, they cannot be burned, they cannot be used for a biodiesel production. So biodiesel production, this 14 zero, you can say 16 zero is there, 18 zero, 20 zero, 22 zero, 24 zero, all they indicates that they are containing mostly saturated fatty acid, means there is no double bond or no triple bond is there. If there is a 18 1, 22 1, 18 2, 18 3, 18 1 indicate mono saturated fatty acid, where one double bond, triple bond is there. Similarly, and the 18, 22, 20 depicts the length of carbon that is present in these oil and fats. And this is, you can see the composition of different kind of fatty acid. And I have told you the carbon length varies in the oil and fat from 16 to 24 and even higher. So this composition decided into, then two double bonds are there, 18 3 three double bonds are there, and we will record and see that very different kind of oil composition is there. 16 0 is 28%, 18 2 is very high, 57%, and you can see 21 is absent, 24 is absent, 22 is absent, 20 0 is absent. And that's why you can see that they varies, every feedstock varies in the different composition. 16 is also known as palmitic, palmitic acid, palmitoleic acid, and then 18 is known as stearic acid, oleic acid, 18 and 18 is linoleic acid, while 18 is linolenic acid. So they are kind of different kind of iodine value based on the composition of what kind of saturated and saturated fatty acid is there, and they also affect the well, probably you will see the comparatively in this table. The cetane number is very high, very good for saturated. The cloud point is also very good, stability is very good. While if there is a presence of monounsaturated fatty acid, cetane number is medium, cloud point is medium, stability is medium, while PFA degrades the quality of biodiesel, and that's why cetane number is very low, cloud point is low, stability is very low. So there are some standard norms that is called the ASTM D2500 and 4 point norms ASTM D97. They have some standard parameters for deciding the best quality of biodiesel, and they are the standard for B112 means if 100% biodiesel is there they may contain such kind of values for the 4 point, for the cloud point. Cloud point I may want to clarify. 4 point and cloud point basically depicts how much will be vaporization, what will be the temperature required for burning, at which temperature they will convert into the gaseous form, and then they can be burned in the engine for. And if you'll see, the heat of combustion is almost compared to the diesel type to diesel. It is very pure. This is 13,300 BTU per pound. And all the plant-based biodiesel, I can say they have very close value heat of production. So very good quality of biodiesel can be obtained using these feedstock. You can see the production process. Production process. The first step is the oil extraction, where milling is done. A seed is pressed to extract a large amount of oil, and then degamming process is there because oil is very viscous, and viscous oil is not allowed for plant certification. Oil must be pure, and then there must be determination of what kind of methanol to catalyst ratio should be there, and then trans-esterification process will start, and then if any kind of acid and base are there in the excess amount, they can be neutralized, and if methanol is there, methanol can be recovered, they can be used again. So there is no wastage, and there is a catalyst also recovered, methanol also recovered. Methanol is costly and they are toxic, so they must be separated, and they can be reused. They also affecting the economy. And then we'll discuss about the quality of biodiesel. Quality of biodiesel can increase by increasing the purifying the glycerin, recovering the methanol, removing the water content. So this biodiesel separation uh, is very crucial for giving a good quality of biodiesel. And then there is the degumming. What is degumming process? Degumming process is actually involve separation of all those content you can see in this diagram. And this is oil, and this is undesirable material, and they can be performed by chemical reaction in which whatever the unwanted material are there, they can settle down at the bottom, while biodiesel is there, and sorry, oil is there, oil and fat is there at the top level, and they can be separated. And then trans-esterification is performed. Well, 10% methanol can be used, and then they can be mixed in presence of sodium hydroxide or potassium hydroxide in a vessel, and then 10% of glycerin is a byproduct, giving the 100% biodiesel. This is the economy. This is the reaction. I have discussed a lot about the trans-esterification, and then I can show you the effect of water content. Water content must be very low, otherwise they are going to affect the quality of methyl ester. You can see the different kind of catalysts there: alkyne catalyst, acid catalyst. This is related to acid catalyst. This is alkaline catalyst. This is a supercritical methanol. Water content is very less, and so the quality of biodiesel will be affected. And this is the free fatty acid content. Free fatty acid content also should be low in the biodiesel production. And then there is a discussion if we can use the ethanol As a trans-esterification, ethanol is more expensive than methanol. So, and also very lowest formation result ethanol is equal to recycle. Ethanol create a viscous type of biodiesel, so this is also not desirable. And also cloud and pour points are badly affected. They are very low, and they are going to affect the quality of biodiesel because they are not able to burn in the engine. So there is no benefit of using this ethanol. Methanol is best. And there are various trans-esterification process like base catalyzed reaction is there, acid catalyzed reaction is there. Then new kind of trans-esterification in these days are very common, enzyme catalyzed, and one supercritical trans-esterification which is performed at very high temperature and pressure. They have their own advantage and disadvantage. If I'm talking about the base catalyzed trans-esterification, a strong base is used where metal hydroxide is used, sodium hydroxide, potassium hydroxide can be used. Alright, and but they have the disadvantage that they are very costly. They are produced very high amount of soap, so they are not desirable. And presence of water, if you have very high amount of water is there, then hydrolysis will not be completed. So there must be drying of the oil so that water content can be removed. The hydrolysis will be very good. You can see the sodium or potassium salt is often called as a soap. They are going to react with the long chain alkyl group, long chain fatty acid group. And these are the soaps which are not desirable. Water is also not desirable. And also, as you can see, if the temperature is very high, at very high temperature, water can highlight triglyceride to form free fatty acids. So water content should be low if in the feedstock. If water content is very high, what will happen? Triglyceride will form diglyceride and free fatty acid will be free fatty acid not desirable. They are going to produce a lot of glycerin. Acid catalyzed reaction you can see one by one. Acid catalyzed reaction this is advantageous as compared to the base catalyzed trans-esterification, but the problem is that they are very slow, but they are very suitable if any such oil is there which contain very high amount of free fatty acid, and whatever the process you can use for strong acid catalyzed esterification, and they can convert efficiency is also very high for the trans-esterification. And also because metal is absent, there is no sodium, there is no potassium, there is no chances of production of soap, right? And then esterification of fatty acid, if any kind of fatty acid is there, free fatty acid is there, the esterification of those fatty acid there is more content of biodiesel, and they are very, the reaction is very fast, but the disadvantage is that they produce very high amount of water. I will see that there is a new kind of trans-esterification where enzyme can be used. The enzyme in place of base or acid catalyzed reaction. Enzyme is going to produce the same kind of products, but the advantage, a lot of advantages there because they produce biodiesel, very high quality of biodiesel. Um, but they are also having the disadvantage they are very expensive, and at no commercial plant have been installed anywhere in the world that should utilize this enzyme trans-esterification, and lipases are the most efficient in this catalysis, and large amount of lipases can be obtained using the microscope candida, and these large amount of research is focused on production of these lipase catalyzed reaction, trans-esterification reaction, and researchers claim that they have very good yield of biodiesel, and they can be obtained, they can be used to trans-estify any kind of crude or any kind of used oils. And lipases has another disadvantage that they're very less sensitive to high free fatty acid content. Means if you have a high amount of free fatty acid is there, they will not be going to be converted into any kind of biodiesel or any kind of product. This is the advantage. But also another disadvantage is that methanol we cannot use in the reaction, because if methanol you are going to use, they are going to destroy, they are going to inactivate these lipases. Lipases will not work further. They will not be able to catalyze any kind of reaction. So very low amount of biodiesel will result. In this case, what we can do, instead of using methanol, we can use methyl acetate, which is not as much toxic over the lipases, and lipases are not going to be deactivated. They are going to um, effectively react with the systems. Whatever the lipases are there, lipases perform the trans-esterification, and they can be obtained from any kind of bacteria and fungi. The fungi are most common, especially Candida is most common in this regard, that produces lipases, and optimal temperature can be maintained so that enzymes should work at best. And in the um, literature, it has been reported that there are more than 90% um, conversion can be achieved if temperature can be maintained at 30 to 50 degrees centigrade. Then the kind of trans-esterification. What is a supercritical condition? Supercritical condition we can define if any kind of liquid is a supercritical when its temperature and pressure are maintained above critical points. Phases are there, gas phases are there, liquid phases are there, and so the critical points and very high temperature required 240 degrees centigrade, and psi pressure of more than 1000 is required. This is the only disadvantage, but they are very effective. You can see for conversion of for trans-esterification reaction for obtaining high quality of biodiesel. No catalyst is required, but they can be used, and they have their own advantages and disadvantages. So we can say them supercritical process is catalyst-free process. There only methanol is used because already temperature and pressure is very high. So methoxyion is produced. Methoxyion is going to attack these glycerides, and glycerides methyl alkyl ester will be formed. And this method is very helpful where you want to avoid any kind of soap formation, and variety of feedstock can be used. There's no restriction to what kind of feedstock can be used. Also, the catalyst remover step is also limited. So they are very beneficial. Only the disadvantage is requirement of very high temperature and pressure, but energy cost is very similar. There is no extra energy cost. So, thank you for listening this lecture on trans-esterification in biodiesel production. We can summarize that if want to produce biodiesel, there should be very good quality of feedstock. And basically, if we talk about the feedstock, rapeseed is mostly used in the journey rapeseed based biodiesel production, while soybean oil is mostly used in the US for production. And algae, if you talk microalgae, these days are very common, very beneficial. They don't interfere with the land agriculture, so containing very high, but the disadvantage that they contains very high amount of unsaturated fatty acid, but there are also algae that they have very less amount of polyunsaturated fatty acids. So suitable source selection must be there. Suitable source must contain less amount of water. More saturated or monounsaturated fatty acids should be there. Low pFa is required, and then trans-esterification can be done by adopting other base catalyst, acid catalyst, enzyme catalyst, supercritical, or sometimes hydroprocessing is there, where in hydroprocessing we can utilize some kind of catalyst, catalyst that perform a catalytic hydrocracking. Good jet quality of biodiesel can be produced. If you'll see some more about trans-esterification advantage and disadvantage, acid catalyzed reaction. In acid catalyzed reaction, ratio of methanol to oil is very high. This is beyond 40, and reaction is also very slow. Corrosion resistant material is required in the engine. And then you have to modify, because if acid is there, they are going to corrode the engines, and they are going to react to the pipe, they are going to react to the injectors, and that is not desirable for the uh, biodiesel engines. But I have told you acid-based reaction is very effective for those oil that contain very high amount of free fatty acid, right? While in the base catalyzed reaction, methanol oil this is very low. Enzyme also you can see that there is a very low amount of methanol is used there, And I can see other processes. They have very normal amount of methanol to add ratio. So in summary, what we can see that there are um, urgent need of biodiesel production, and but suitable kind of feedstock should be there, which must be available around there, which must contain right kind of composition, and also the stability is important, and the storage quality is important in describing all those features, so that a very good quality of biodiesel can be produced. Thank you, friends.